let's try to solve this problem here. A stationary wave is represented by the following expression: y is equal to 5 cos pi x and sine pi t. Okay, again, it's a stationary or standing wave because it has a cos and a sine being multiplied together. Okay, y and x is in centimeters and t is in seconds. So right now, all the distance that we'll be seeing in this question will be measured in the unit of cm. Okay, determine the 3 smallest value of x, so which 3 position, which is not at the origin, that corresponds to nodes and antinodes. So to understand that, right, we need to probably sketch a stationary wave to roughly understand the concept. So let's try and sketch a stationary wave. So let's assume this is the equilibrium position. So a simple standing wave would look something like this. Okay, so a standing wave, it will not travel through space. It will just oscillate in its own place. So you can imagine at the future time, it will probably oscillate to a level that looks something like this. Okay, then even later time, it might flip to the other side. Okay, and even later time, it will reach its amplitude, but on the opposite direction. Okay, something like this. So what I'm trying to display here is that the standing wave is not traveling through space. You are not seeing it moving to the left, you are not seeing it moving to the right. It is stationary, remaining at its place. But what's changing is the size of the, what do you call it, the ears of the wave. The size of the ears of the wave is changing with time. Okay, so we can see that because it is not moving, right, there are certain points in this standing wave that does not change its displacement. Its displacement is always equal to 0. Okay, let me highlight these places. Okay, the displacement here is always 0. It never goes up, it never goes down. Here as well, here as well, here as well, here as well. So these points where your amplitude, where your displacement never goes to other number, is always at 0. We call this kind of position as the nodes, maybe as n. Okay, so we can see clearly that for situations such as a node, okay, because your displacement is always 0, that means by the amplitude of the standing wave at this position, where's the highest you can go in this position that we call as nodes, the highest position that you can go in this position is 0, because you can never go more than 0, you can never go less than 0. You're always at 0, so your amplitude for standing wave at this position is always 0. Okay, how about the other one, the antinode? Okay, antinode, we know that it's in between two nodes. In between two nodes, you have an antinode. You have an antinode here. You have an antinode. You have an antinode here. You can see that at these places that we label as A or antinode, at these places, you can see that the maximum that you can achieve is higher than anywhere else. Okay, you can observe in this whole wave, in this whole standing wave, you can observe that at the antinode, the highest or the maximum displacement that you can achieve at these antinodes, it's higher than anywhere else. Okay, I'll highlight in green. What does it mean by anywhere else? Let's look at this position. At this position, the highest you can go is here. At this position, the highest you can go is here. But for the antinode, you can see that the highest that you can go is higher than anyone else. Okay, it's basically the highest, the maximum that you can achieve. Okay, so we can actually say that the amplitude at the antinode is maximum. Okay, the amplitude at the node is 0, but the amplitude at the antinode is maximum. Why is it maximum? Because there's nowhere else that has the same amplitude as the antinode. The antinode has the highest, or the greatest amplitude that can be achieved in this whole standing wave. Okay, so let's write it down. So antinode is in blue. you can see that it has the most vigorous displacement. Then let's just skip straight to the endpoint. We can see that the amplitude of the standing wave at this antinode is maximum. And if we know what is maximum, maximum actually means that the amplitude of the standing wave is equals to 2 times of the amplitude of the progressive wave. Okay, let me elaborate a bit more. Okay, so we know that y is equals to 5 cos pi x sine pi t. Okay, this is a standing wave equation, so we can compare with the general equation of standing wave, which is equals to 2a cos kx sine omega t. Okay, as we can see here, by doing a simple comparison, we can see that 2a here is representing the maximum amplitude that can be achieved. Okay, this is not amplitude, this is maximum amplitude. Different places have different amplitude, but the maximum amplitude that can be achieved is 5. Okay, and we see that 5 is actually equals to 2a, but this a here is the progressive wave amplitude. This is a progressive wave amplitude. This is the standing wave maximum amplitude. So we can see that the relationship here is, this is A for standing wave maximum is equals to, this A here is APW. That's why, seeing these two things, we can see that A standing wave maximum is equals to 2 times of amplitude of progressive wave. And we know that maximum happens at the antinode. That's why you can say that A standing wave at the antinode is equals to 2 times of the amplitude of the progressive wave. Okay, so just a rough idea to differentiate what is the maximum amplitude of standing wave, what is the amplitude of the progressive wave. They are two different things, and the relationship between them is that the amplitude, the maximum amplitude of the standing wave is equals to twice the amplitude of the progressive wave that make up the standing wave. Okay, so I hope we are clear with that. If you are not very sure about it, please refer back to the lecture video. I think it's explained quite in detail over there. Okay, let's continue our comparison. We have k is equals to pi, and we have omega is equals to pi as well. Okay, so you can extract it out. Okay, let's extract it out just in case we need to use this value. We know that 5 is equals to 2a. That's why a is equals to 2.5. This 2.5 here, have to be careful. This 2.5 is in cm, because right now they say that y and x is in centimeter. Okay, next, k is equals to pi per cm. Okay, everything regarding distance is in centimeter. Omega is equals to pi radian per second. Okay, so let's look at the question. 3 smallest value that correspond to nodes. Okay, so let's analyze nodes first. What do we know about nodes? We know that at the nodes, our amplitude of the standing wave at nodes is always equals to 0. This is what we know. Okay, and we know that the amplitude of a standing wave can be obtained using the front part of the equation. Okay, let me clear things up. The amplitude can be obtained using the front part of the standing wave equation, but with a modular sign. Okay, so the amplitude is equals to 2a cos kx. Okay, make it more specific for this situation. Standing wave is equals to 5 cos pi x, which is what we are able to see here. this is the amplitude of the standing wave. Okay, so now if we are clear, we know that this standing wave amplitude should be equal to 0 at the node. So we can substitute 0 to replace the left hand side. So now you have 0 is equals to 5 cos pi x. Okay, so 0, you bring the 5 to the left hand side, take the 0 divided by 5, you get 0 as well. So now you can proceed to do inverse cosine. Inverse cosine of 0 will be equals to pi x. Pi x will be equals to, okay, what's inverse cosine of 0? If you think about a cosine graph, 0 will be at the position where you have pi over 2, you have 3 pi over 2, 5 pi over 2, and so on, so on. They ask for 3 only, right? So you provide 3. Okay, so from here you can see that x is equals to, you bring the pi to the right hand side, divide by pi for everything, you get the answer half a cm, 3 over 2 cm, and 5 over 2 cm. So these are the 3 smallest value that corresponds to node. So that means by over here, what you can see is that over here, x is equals to half cm. Over here, x is equals to 3 over 2 cm. Over here, you see x is equals to 5 over 2 cm. That's basically the idea. Okay, next let's talk about antinode. Okay, you need another 3 position for antinode. Start up here. Antinode, we know that the standing wave amplitude will be equals to maximum. So maximum, we know that is equals to 2 times of progressive wave, and 2 times of progressive wave is actually equals to 5. Okay, you can look at it over here. 2 times of amplitude of progressive wave is equals to 5. So you can write it as 5 cm. Okay, so now using back the same equation, amplitude of standing wave is equals to modulus 5 cos pi x. If you substitute in the 5 inside, oh, sorry, cos pi x. Okay, I'm replacing the amplitude of the standing wave. I'm replacing it with 5 cm over here. Okay, there's still a modulus sign. So modulus means when there's a plus and a minus version. I'm going to be a bit swap some technicalities under the carpet. I'm going to straight bring the 5 over to the left hand side and call it as plus minus 1. Okay, usually if you do it properly using maths, you have to split into a positive version of equation and a negative version of equation. But now I'm just combining them together and call it a positive and negative one. Just because I'm too lazy to write 2 versions of it. Okay, I swip it to the left, so now I'm left with cos pi x on the right. So right now, I can say pi x and do inverse cosine. It's not the best way to do maths, Probably some maths lecturer will be scolding me right now for putting a plus minus inside inverse cos. Yeah, but I can't be bothered. Let's continue. Pi x. Okay, where do you find your inverse? Where do you find your cosine graph to be at 1 or negative 1? You find 1 and negative 1 for your cosine graph at 0, at pi, at 2 pi. But because it's 0, we don't want any value that is equal to 0. We want it to be greater than 0. So let's give one more, which is 3 pi. Okay, so these are the values. So you can see from here that for antinode, x will be equals to 0 cm. Divided by pi, you get 1 cm, 2 cm, 3 cm. Okay, so of course they ask for the first three smallest value greater than 0. So these are the first 3. Okay, so what does it mean here is that if you go find where are the antinode, you find the antinode to be equals to the first one will be at 0 cm, Second one will be at 1 cm. The next one will be at x is equals to 2 cm. The next one here will be x is equals to 3 cm. So this is where you find your antinode. Okay, so I hope we are clear. Okay, one thing that many students might have issue with is that if you do inverse cosine of 0, if you key it into the calculator, probably the only value you get is pi over 2. But where do I get all these other values, right? You have to come back to your concept for mathematics. Okay, if you plot a cosine graph, sketch and plot. If you sketch a cosine graph, this is how cosine graph looks like. Y and X. What this thing here means, okay, what does inverse cos of 0 means is that if y is equal to 0, what is x? What is these values over here? Okay, your calculator will only give you the first one, which is pi over 2. Okay, but there's also other value, which is 3 pi over 2. There's 5 pi over 2 as well. So you need to refer back to your cos graph, cosine graph in order to determine the first 3 values. Okay, same for this one. If you do inverse cosine of plus minus 1, plus 1 is over here, minus 1 is over here. So where do you find plus and minus 1 for your y? You find it here, you find it here, you find it here, you find it here. This one will be, oh sorry, I used dash line right just now. This one will be 0, which is the first one that we write over there. Okay, but you also have pi. You also have 2 pi. You also have 3 pi. So if you key it into the calculator, the only thing you will get is 0. But if you refer to the cosine graph, there's many other values that you can get. So this is how we determine this 0, pi, 2 pi, and 3 pi over here. So I hope you are clear. If you do inverse cosine, if they ask for 3 smallest value, you need to refer to the cosine graph to know what are the other values, not just the one that the calculator show you. Okay, so this is question A. I'm going to move to the next video for question B.